Hello everyone, so we are back again with another lecture, that is failure theory problems. Okay, so here we are going to discuss some of the problems of failure theory. That is in the last class we have discussed about the various failure theories. Okay, so we will just go through the problems, and I will give a next video for that, so that these problems can be solved here. Okay, so here we are just giving the question, that problem that a cylindrical shaft made of steel of yield strength 700 megapascal is subjected to static loads consisting of bending moment 10 kilonewton meter and a torsional moment 30 kilonewton meter. Okay, so determine the diameter of the shaft using two different theories of failure and assuming factor of safety is equal to 2. Take E is equal to 210 gigapascal and Poisson's ratio is equal to 0.25. Okay, so I will just explain this problem, and I guess that you solve this problem and verify the answer, so it will be a bit of practice for you also. Okay, so here first of all, let's note down what is given in the question. Okay, so here sigma is given as, that is yield strength, is given as 700 megapascal. Okay, so we need to convert this megapascal to Newton per mm square. Okay, and this bending moment, that is capital M. If we consider bending moment as capital M, we are having 10 kilonewton meter. Okay, so this 10 kilonewton we need to convert it into Newton millimeter. Okay, similarly torsional moment, that is capital T. If we consider it capital T, then torsional moment will be 30 kilonewton meter, and again this 30 kilonewton meter needs to be converted into Newton millimeter. Okay, so next we have to determine the diameter of the shaft. If we consider the diameter of the shaft as small d, okay, so using two different theories of failure, means you can use any of the theories of failure. You can use maximum shear stress theory, principal stress theory, any theory. Okay, so with the help of any two different theories, we need to find out the diameter of the shaft. Okay, so problem is very easy. We have all the formulas given. We need to just put the values against each term, and we need to find out the diameter. Okay, so here factor of safety is given as 2. Okay, factor of safety is given as 2, and this capital E, so capital E is what? Modulus of elasticity. Okay, or Young's modulus. It is given as 210 gigapascal. Again we need to convert this gigapascal into Newton per mm square. Okay, and Poisson's ratio, very importantly, Poisson's ratio is 1 by small m. Okay, we consider Poisson's ratio as 1 by small m, and 1 by small m is given as 0.25. Okay, so here you need to just put the values against each formulas that has been discussed in the last class. Okay, and we will get the value of small d, that is diameter of the shaft. Okay, so students, you can just try this problem by yourself. Okay, so that it will be a practice for you all. Okay, next another problem. Okay, so here you can see a mild steel shaft of 50 mm diameter is subjected to a bending moment of 2000 Newton meter and a torque T. Okay, so if the yield point of the steel in tension is 200 megapascal, find the maximum value of this torque without causing yielding of the shaft according to maximum principal stress theory, number 2 maximum shear stress theory, and number 3 maximum distortion strain energy theory. Okay, so here what is given in the questions, let's find out first. Here it's given that a mild steel shaft of 50 mm diameter. Okay, so here you can see the diameter. That is, in the previous problem what we need to find out, that we need to find out the small d. Okay, so here small d, that is 50 mm, it's already given in the question. Okay, so next, bending moment 2000 Newton meter. Okay, so 2000 Newton meter bending moment is given, which we need to convert it into Newton millimeter. Okay, next T. Okay, so what we need to find out the value of torque T. Okay, so the formulas will be the same one, but here just we need to find out the value of T, and in the previous problem we had to find out the value of small d, that is diameter of the shaft. Okay, so here yield point is given as 200 megapascal. Okay, so if we need to convert this megapascal into Newton per mm square, and after that we need to find out the value of torque by using the different theories, that is maximum principal stress theory, number 2 maximum shear stress theory, and number 3 is the maximum distortion energy theory. We have got all the formulas for these three theories. We have got all the values. We need to just put the values in their respective formulas, and we need to calculate the value of T. Okay, so we need to calculate the value of T. Okay, so I hope you can just solve this problem and kindly verify it with me. Okay, so with this we have come to the end of this problem solving lecture. Thank you everyone.